Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 5, Lesson 6, Session 1, and it's use properties of operations to add, subtract, multiply, and divide. All right, so learning targets include I can solve problems involving rational numbers. I can solve multi-step real life and mathematical problems posed with positive and negative rational numbers in any form. And I can use patterns and structure to simplify problems that involve more than one operation. Okay, so first problem that they give us is a diagram of the Earth broken into temperature zones. So it says the average daily temperature of the different zones of Earth are shown. The formula F equals C times 9/5 plus 32 can be used to find temperature in degrees Fahrenheit when you know the temperature in degrees Celsius. Then it says, what is the average temperature at the North Pole in degrees Fahrenheit? So if we look at the diagram here, they give us the temperatures in Celsius. And the North Pole's average temperature is 23 below 0 Celsius. And the question's asking, what would that temperature be in Fahrenheit? So what could we use to solve this problem? Well, we have to use a formula, and that's always step one. So let me highlight this. Always, 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 step one, write the formula. So I'm going to write F equals C times 9/5 plus 32. Okay? So there it is right here. So an order of operations tells you what order to perform operations in a numerical expression. So let's talk about that a little bit. A numerical expression is right there. Excuse me. This is an expression, but as soon as I include an equal sign and something on the other side, now that is an equation. Okay. So in what order should you perform the operations to evaluate this when C is equal to negative 23? So the first step is always substitute in your answer. So I'm just going to rewrite. Let me get rid of that and switch to pen. I'm going to rewrite the equation. F equals C times 9/5 plus 32. Always rewrite the problem. So step one, write formula. Okay, we were given that formula in the first, or a couple pages ago, third page, I guess. Step two is substitute the givens. Okay, so what am I substituting? Well, they told us that C equals negative 23. All right, well, there's C right here and there's C right there. So we're going to replace this C with negative 23. So I'm going to write F equals negative 23 times 9/5 plus 32. Okay, substitute the givens. Step three is simplify and solve. Okay, so I'm going to simplify this and solve it. Well, 5 will not go into 23, so I can't do an easy reduce here. 23 is prime. So off to the side here, I'm going to take negative 23, and I'm going to multiply it by 9. 9 times 3 is 27, carry the 2. 9 times 2 is 18, plus 2 is 20. So negative 23 times 9 is negative 207. I then need to divide it by 5. So that's what multiplying by a fraction is. You multiply the number by the numerator and then divide it by the denominator. So now I want to know how many times 5 will go into negative 207. Okay, 5 goes into 24 times with no remainder. 5 will not go into 0. So I bring down the 7. 5 will go into 7 once. Okay, so I just brought this down. 5 will go into 7 one time. And 5 minus 7 is 2. And 5 goes into 20 4 times. Okay. So I got 41 41.4. And the sign is negative because a negative times a positive is negative. So now I'm going to replace that with negative 41.4. And you can always use a calculator to check your answer, but never, you shouldn't use a calculator to do a problem. Okay. Always try to, what's this doing? Okay. Always try to do a problem without using the calculator and then check. So I want to take, what were my numbers? 9 over 5 times negative 23. So 23 times 9 is 207 divided by 5 is 41.4. Okay, just double checking. And then I'm going to add 32. So it's negative 41.4 plus 32. So in order to find that, we take the absolute value of negative 41.4, which is 41.4. We take the absolute value of 32, which is 32, and the signs are different, so we subtract, and we get 4 minus 0 is 4. We need to borrow here. 11 minus 2 is 9, so we get F equals 9.4, but be careful when the sign of the larger number is what we take. The absolute value of 41 is more than the absolute value of 32. 41 was negative. My answer is negative. So my answer is Fahrenheit temperature is negative 9.4 degrees. Okay? So that's how we solve problems like this. Substitute, simplify, solve. And it doesn't hurt to check your answer when we're done. Okay? So here was the steps. Replace C with negative 23. They changed 9.5 to 1.8, or 9/5 to 1.8, which is fine. We can do that. I did it using the fraction by multiplying by the numerator, then dividing by the denominator, which gave us the same value. But negative 23 times 1.8 is negative 41.4, plus 32 is negative 9.4. So if you struggle with using fractions and multiplying this and then dividing, you can always change a fraction to a decimal first and then multiply. Okay, so what is the average temperature at the North Pole in degrees Fahrenheit? Well, the average temperature at the North Pole in degrees Fahrenheit is negative 9.4 degrees Fahrenheit. So then it says, let's explore more. How do the temperatures of the equator, the equations of the equator, how do the temperatures of the equator, which is right here, equator, and the South Pole compare in degrees Fahrenheit? So whenever we see the word compare, 3 outcomes are going to happen. When you compare two numbers can be equal, one number can be greater than the other, or one number can be less than the other. That is what we're asking for when they say compare. How do we compare these two numbers? Well, negative 33, if we want to know how far apart these are, we take the range, so it'd be the greater negative number, or the greater number, depending on how you do this, minus the lower number. Let's do it this way. Take the greater number, which is 26 degrees, and subtract negative 33. Well, 26 minus a negative means plus. 26 plus 33, 6 plus 3, I'm adding these. 6 plus 3 is 9, 2 plus 3 is 5. That's a difference of 59 degrees. So what we could say is the equator has an average temperature that is 59 degrees warmer, and I'll put a C for Celsius, than the temperature, average temperature of the South Pole. Okay, so that is a comparison of those two. Okay, but that was in Celsius. Okay, so unfortunately, they said degrees Fahrenheit. So I need to convert the temperature. So this temperature, this value is going to change, and that's the only thing that's going to change. So I'm going to leave everything else. Okay. I did that on purpose, but I want you to be aware that whenever you're doing a problem, you need to read the question over again, and you need to make sure your answer is correct. Okay. So they weren't asking for Celsius. So what do we need to do here? Well, we need to convert using this formula for both. Okay, so let's go back to here. So now I'm going to erase all this just so I can work. And I'm going to write F equals 9 over 5C plus 32. And I'll do the equator first, which is 26 degrees. So F equals 9/5. And let's change that to 1.8 like they did in the example. Okay, and I think they put the C first. It does not matter. Multiplication is commutative. So C times 9/5 is the same as 9/5 times C. But let's just do it this way. And the Celsius temperature is 26 degrees at the equator. And I'm going to multiply that by 1.8, which is 9/5 plus 32. So if I take 26 times 1.8, I get 48. 6 times 8, 8 times 2 is 16, and 4 is 20. 0, 6, 2. I get 8, 6, 4 with one decimal place. So that is 46.8 degrees plus 32. Okay? So the average temperature in Fahrenheit at the equator is 0.8. 6 plus 2 is 8. 4 plus 3 is 70. So the average temperature at the equator in Fahrenheit is 78.8 degrees. Now I need to do the same for the South Pole. So here's my formula. Substitute the givens. Let's change that to 1.8. So there's my substitution. And now if I take negative 33 times 1.8, 8 times 3 is 24. I carry the 2. 8 times 3 is 24 plus 2 is 26. Bring a 0. 3 times 1 is 3. 3 times 1 is 3. Add 4, 9, 5, 1 decimal place. This is 59. Oh, by the way, it's negative 0.4 plus 32. Okay? So if I take 59.4, which is my absolute value of negative 59.4, and I subtract 32, okay, because the signs are different, I get a difference of 4. 9 minus 2 is 7. 5 minus 3 is 2. So the Fahrenheit temperature average is negative 27.4 degrees. Okay, so now I found the Fahrenheit temperature at the equator and the Fahrenheit temperature at the South Pole. And now I say the equator has an average temperature that is blank warmer. So I'm going to take 78.8 minus a negative 27, which is plus 27.4. 8 and 4 is 12, carry the 1. 8 and 7 is 15, plus 1 is 16, carry the 1. And I get 106.2. So the equator has an average temperature that is 106.2 degrees warmer than, that should be than, not the, my fault. It should be than the average temperature of the South Pole. Okay? So that is the exploration real world problem in this section. I believe that's the end of session 1. Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 5, Lesson 6, Session 2. Use properties of operations. Okay, so order of operations. So I'm going to write the acronym for that, and I don't use a P. A lot of people say PEMDAS. I use a G. And the reason I use a G is because G covers more things, grouping. So when I say grouping, it could be something under square root. It could be in absolute value brackets. It could be in parentheses. It could be a number of things. These are all groupings. If I just put a P there, this would be the only one that'd be addressed. So I use GEMDAS. Grouping, exponents, multiply, divide, add, subtract. And I'm going to add to this whenever we're down to just multiply and divide. You do left to right. And the same goes with adding and subtracting. If we're just adding and subtracting, you do left to right. Okay, so with that being said, this is actually substitution, this problem. So the first thing I always like to do is rewrite the problem. W divided by xy plus y minus z cubed. It says, what is the value of this expression if W is 36? So now I'm going to substitute these in. I'll use red for W. I'll use green for X. And I'll use blue for Y. And I'll use Z is going to be purple. Okay. So W is 36 divided by X is -6. And we're multiplying that by Y, and Y is -1. So that's just this part. And then it's plus, and then Y again, and then minus, and then Z, which is -2. And we're going to take that to the power of 3. So all I did from here to here was substitute in the values they told us they were. So now we're going to do order of operations. So I'm going to look at G. So let me do this. Let me highlight. Any groups? We have groups. A group right here. So any operation within a denominator or any operation within a numerator is also considered a group. We want to do that first. So we're going to just leave 36 as is. And then we're going to simplify. And a negative times a negative is positive. 6 times 1 is 6. Okay? And then we're going to do plus -1 minus -2, and that is going to be cubed. Okay? So let me move this down here. Let me group these. Just give me 1 second. I'm going to group these and just drag them down so that they're still in view while we're doing this. So I'll move these here. I know I'm in the way there. There we go. Okay, so now we're going to do, we did the grouping. We're done with that. What's the next step? Well, oops. How about I deselect that and get my highlighter, and let's use green. So exponent is next. I'm going to leave everything as is. I'm going to leave 36 over 6 plus -1 minus, and now I'm going to address this. So -2 to the third power, -2 to the third power means -2 times itself 3 times. So -2 times a -2 is a positive 4. Multiply that by a -2, and I get a -8. So this was a discussion in class today. A negative to odd powers stays negative. A negative to even powers is positive. So here's a, right here, -2 times -2 would be -2 squared. That's +4. add another -2 to it. Now there's 3 of them. That would be a power of 3. It became negative. And if I did it again, this would be to the 4th power, and that would make this positive 16. So it oscillates from negative to positive, negative, positive. So if the power is negative, I'm sorry, if the power is odd and the base is negative, then the result is negative. If the base is negative and the power is even, the result is even. Okay, so we've addressed the exponents. The next thing we want to do is multiplication. Okay, there is none. So we skip that, move on to division. So 36 divided by 6 is 6 plus my -1 minus -8. So now that we are down to addition and subtraction right here, that's the next thing we're going to focus on. So the last thing we're going to do is add and subtract, and we work left to right because that's all that's left. So this 6 here, what's this doing? Just get rid of that little mark. 6 plus a -1 we're going to do first. Well, that's 6 to the right, and then back 1, that gives us 5. Minus a negative, I'm going to change that now to plus, and it's 8. And 5 plus 8 is 13. Okay, so that's how we find the value of an expression given values for variables. Okay, so now it's asking, is -2 to the 3rd power positive or negative? Explain how you know. Well, I've already explained that on the last slide, so I'm not going to spend more time here. When you have a negative base, okay, so for starters, let me just write that. This is called a base. Any number that we take to a power is called a base. So the base is here, the base is -2, and the exponent or power, it could also be called exponent, we also say power, is the number up here. So anytime you have a negative base, it could either be positive or negative depending on your exponent. This exponent's odd, therefore the answer is negative, and I explained that on the last slide. Okay. So then they finish the other problem that I've already done. I'll skip over that. And it says, think about it. Is -2 to the 793, so let me get my highlighter. The base is negative. The exponent is odd. The answer, therefore, will be negative. Okay. So now it says, what is the value of this expression? Well, they're just asking the same thing over and over. We got the answer already. It is 13. And now we're going to move on to here. Now it says, suppose a classmate found W over XY first. Okay, now let me go back here. I'll do that on this page. So let me just get rid of this thing here. Let me just get rid of this. Okay, so we're going to do this problem again. So let me write it. I won't color code this time. W divided by XY plus Y, oops, not equals, minus Z to the 3rd power. So the next problem says, suppose a classmate found W divided by XY first, then added Y and subtracted Z in that order. So let's do W over XY first. Where did it go? W over XY first. Well, we need to substitute. So W is 36 divided by XY, which is -6 times -1 plus Y, which is -1 minus -2 cubed. So this problem said, suppose a classmate found W over XY first. So let's do that. This would be 36 over 6 plus -1 minus -Z squared. and that would become 6 plus -1 minus negative, I forgot to put my z in. Let me fix that. I didn't substitute my z. Z is -2. Not, I did, but it looked like a z. -2 squared. Okay, so we did this first. That's what the problem said. Suppose a student did that first, then added y. So now let's do that. So where's y? Y is right here. So they're saying now add y. So 6 plus a -1 is 5. So then we have minus a -2 squared. And then it says, and then subtracted z. So if I subtract z, then that would be 5 plus 2, which is 7. And then we have this squared, and then, or not squared, that's to the third power. I dropped it from 3 to 2. That should be a 3. Sorry about that. This is cubed. This is cubed. This is still cubed. This is still cubed. And 7 times 3, or 7 times 7 is 49. And then multiply that by 7 is 63. 7 times 4 is 28. Plus 6 is 34. So that's 343. Okay. So this says what would be the result and why is it incorrect? Okay. So we should have gotten 13. But if we did it with this first and then this and then this and then this, just going left to right, everything, we got 343. The reason it's incorrect is when you have parentheses and a cubed value, that number is the only thing being cubed. This should be 8, -8. When we're just working left to right, we're changing the base to 7. And 7 to the third power is a lot bigger, as you can see, 343, than 2 to the third power, or -2 to the third power, which is -8. Okay. So that's why it's incorrect. Now it says when simplifying, -7 times 3 times -10 plus a -4, you can multiply 3 and -10 first and get the same result as multiplying -7 and 3 first. Explain. So let me extend this page here so we can work. So now we're looking at B. So we're going to do this twice. So it says when simplifying this, you can multiply 3 and 10 first. So they're asking us to do this first. Excuse me. So if I do -7, 3 times -10 is -30 plus a -4. Okay. So we need to multiply. Remember, it's GEMDAS. So there's no grouping in this case. There's no exponents. So the first thing we have to do is multiply. So we multiplied this first, and now we have to multiply this. Well, negative times a negative is positive, and 7 times 30 is 210. And then plus a negative means minus, and 210 minus 4 is 206. Okay? So then I'm going to do it again, but in this time I'm going to multiply -7 and 3 first. Okay, so that'd be -7 times 3. We're going to do this part first this time. So I'm going to rewrite it. -7 times 3 times -10 plus a -4. And I'm going to do this first. And that's -21. And then I'm going to multiply that by -10 plus a -4. Oops, not 4D. -4. So negative times a negative is positive. 21 times 10 is 210, and plus a negative is minus, and we get 206. Why was this okay? The reason it was okay is because besides this plus a -4, you have to do multiplication first, and since there was 2 multiplication ways to do the multiplication, that is called the commutative property of multiplication. And what that states is A times B equals B times A. In other words, order does not matter. And obviously, that comes out to be true. Okay. Apply. It's cold outside. It is cloudy year-round in Lethbridge, Alberta, and the temperature can vary from 13 degrees Fahrenheit to 81 degrees Fahrenheit. Why they're doing it in Fahrenheit, I have no idea. Canada uses the Celsius scale. The graph shows that 1 week in December was particularly cold for this region. So the red are daytime highs and the blues are nighttime highs. Okay. So it says choose a question to answer. What was the average difference between daytime and nighttime temperatures during the week? So in this problem here, we have to do averages. Average difference. Okay. So what I'm going to do here is I'm going to copy this, move to a new screen. Shrink it down. All right, so here we go. What I'm going to do is I want to take the difference between the high and the low, and I'm going to say this looks like it's -3, and this looks like -13. Oh. So I'm going to put day on the top and night on the bottom. Okay? And do a table. So in the daytime, the red, -13 on the 25th, and at night, it was -3. And then on the 26th, daytime high, -15. Nighttime high looks like -32. On the 27th, daytime high looks like +1 degrees, and the low looks like -29. I could be off by a degree here or there, but that's okay. You have to work with the unit of measurements they give you on the grid. So this looks a little less than 15, so I'm going to call it 14. And this looks a little bit colder than -10, so that looks like -11. Okay, so that's what? 25, 26, 27, 28. We're on the 29th now, and that's 16. And that looks like -11. Did I do this one wrong? I did. This -11 is here, and 14 was here. I should have gone down here. That's -24. So let me fix that. So 14 here, right here, 14, -24. 16, -11. Okay. Then it dropped to -6 for a high during the day. And it looks like -22. And finally, 25 and -22 again. Okay. So let me get a number line. The distance between 2 points, sometimes both positive, sometimes both negative, sometimes one positive and one negative. It's a good idea to have a number line to express what their sums are, their distances away from each other, because that's what we're doing. We're looking for a range. So -13 to -3, well, -3 is right here, and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is here. So the distance from here to here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, So I'm just going to do all of these like that. So that was a difference of 10 degrees. Without using the grid, though, I'm just going to get rid of these numbers now. Now we have negative 15. So let's call this negative 15. I don't know what I'm writing. Negative 11.5, negative 115. How about negative 15? And then negative 32 is down here. So when they're both negative, the distance between them is the numbers just subtracted. And that's 17. Okay. So we went left 15 and then left 17 more to get to negative 32. Okay. Here's where it might get confusing. We have a plus 1, we have a negative 29. So if 1 is over here, let me erase these. And we have negative 29 right here. What we're really doing is saying, okay, how far is negative 29 from 0? And it's 29. And then how about doing another one in a different color? Okay. And we want to ask ourselves, how far is 1 from 0? It's on the other side, but it's still a distance of 1. So if this black piece is 29 and this green piece is 1, the total is 30. Okay. Again, we have 14. So think of this. I'm not going to use numbers anymore. Let's just drag this over and write it on there. That's 14. Okay. And this is negative 24. So it's distance of 24 from 0. That'd be a 4 now. This is 24. This is 14. That's a total of 38. So when one's positive and one's negative, you just add them. 16, this is opposite. So 16 to the right, negative 11's the other way. That's a difference of 27 degrees. And these are the same, so we subtract. 22 minus 6 is 16. And these are opposite, so we add. 25 and 22 is 47. Huge difference on that day. Okay? So I wanted to explain that using a number line. Let me just get rid of all this now. Okay. And now we want to find the average of these numbers. So if I take 10 plus 17 plus 30 plus 38 plus 27 plus 16, whoops, missed, plus 47, and add these, we get 7 and 8 is 15, 22, 28, 35, carry the 3. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 4 is 18. So we have 185 total degrees, and then we divide by how many there are, which is 7 days in the week. 7 goes into 18 2 times, giving me 14. 8 minus 4 is 4. Bring down the 5, 45. 7 times 6 is 42. Subtract. Need another 0 here to bring down. And 5 minus 2 is 3. And I didn't bring this down far enough. Oops. This should be below. 7 goes into 30 4 times. 7 times 4 is 28. Subtract. 30 minus 28 is 2. Bring down another 0. And 7 times 2 is 14. And it said back here to round your answer to the nearest half degree. So is this 26 degrees or 26.5? This would round to approximately 26.5 degrees Fahrenheit is the answer. Okay. So we're going to do it again. Bring this over again, and I'm going to do part 2. Question 2, the nighttime temperature decreased by 20 degrees during the course of the week. What they're saying here is the nighttime temperature decreased from here to here. From the start of the week to the end of the week, it decreased how many degrees? 20 degrees. Okay. Where does that go? There we go. 20. So it decreased. So on this red line, it went down 20 degrees. Okay. So we went from -3 to -23 is what it looks like, or -2 to -22. That's a drop in of 20 degrees. Then it says, how can you represent, the nighttime temperature decreased by 20 degrees during the course of the week. How can you represent the increase in daytime temperature from the 25th to the 31st as a product of -20? So if I go back to here, what they're asking for now is, let me get a straight line, and let's change it to green. What they're saying is at the beginning of the week, it was here, and at the end of the week, the temperature rose all the way up to there, and we need to find out how much it went up. And that difference is it went from -13 all the way up to 25, and that is a spread of 38 degrees. So if I represent the value, I'd say -20 times some number equals 38 degrees. Okay? If I'm interpreting that correctly, how can you represent the increase in daytime temperatures from the 25th to the 31st as a product of -20? So -20 times something equals 38 degrees. To get x by itself, we divide by -20. These cancel and I get x equals, okay, and I'm going to take 20 and see how many times it goes into 38. And my answer is going to be negative because a positive divided by a negative is negative. So 20 goes into 38 once. And when I subtract, I get 18. And then I bring down a 0. And 2 goes into 18 9 times evenly. So I get 18. 9 times 20 is 180. And I get a remainder of 0. Just disregard that decimal there. So the answer is 1.9. And it's negative. Okay? So I would say -20 times -1.9 equals the amount it rose in that week. Okay. That is the end of session 2. Thanks for watching and have a great day.